So today we will talk about the complex reactions and the simple reactions as well. Okay, there are certain reactions which are not single step reaction. Like there is a lot of complex mechanism behind the reaction. We consider that we have a reaction which is 3A plus 2B is equal to C. Like if you're writing uh, uh, if you look here, so you will imagine that it is very simple. No, it is a very complex reaction. There are a lot of steps behind this reaction. Let's talk about the steps. We consider that 2A plus B is equal to P, right? Number second is P plus A is equal to Q, and number 3 is Q plus B is equal to C. So this is basically the mechanism behind this reaction. This is a mechanism. It is very complex reaction, right? There are two types of reactions, either complex or simple. Simple are the one which take only one step to complete to make the product, but this is complex which take a lot of steps to complete. Take a lot of steps to complete reaction, right? These reactions are known as complex reaction. So in this reaction, how you find out the rate of reaction, right? You want to find the order of reaction, right? How you will find? Okay, basically in these all reactions, in this whole mechanism, there will be one step that will be very slow. Consider that this is the slowest step. This is the slowest step. The step which is very slow in a complex reaction, that is known as rate determining step. That is known as rate determining step. The step which is very slow, that is known as a rate determining step. Okay, so this the coefficients of this step will be utilized in the rate of reaction. If I want to write the rate of reaction of for this equation, for this whole reaction, what I will do, I will write rate of reaction is equal to K A 2 and B. Now you will be wondering why I am using this reactions coefficient. I'm using these coefficients. Why? Because this is the slowest step in a complex reaction. How will find the rate of reaction? The step in which is very slow, that is known as rate determining step, and its coefficients will be utilized in the rate of reaction. Here, now this reaction's coefficient will be utilized. So step which is the slowest, their stoichiometric their stoichiometric coefficients will be used, right? If I ask you that what be the rate of reaction for this, if you wrote this rate of reaction, that ROR is equal to K A3 and B, so I'll say this is basically wrong, right? But if you wrote this one, I'll say this is the right. Why? Because this involves the coefficients which are of the slowest step. So the slowest step is basically known as rate determining step. So I hope this mechanism is clear to you, that how we find the rate of reaction by just seeing the slowest reaction. Now let's talk about the simple reactions, right, which take only one step to complete, right? Simple step reactions, or you can say elementary single step reaction. They are also known as elementary single step reaction, right? Consider we have a reaction which is 2x plus 3y is equal to 4z, and it is a very simple reaction, means it will take only single step. So if I ask you that what will be the rate of reaction, so the ROR will be equal to K x2 and y3. So now you will be wondering why I have used coefficients, because they involve only one step. So that one step will be the slow. That one step will be slow. So that will be rate determining step. The slow step is the rate determining step, and they have only one step. So that step will be known as rate determining step. Right? Consider that. Let's take an example, real life example, which is H2 plus I2, and they make hydrogen iodide, right? If I want to write, this is very simple reaction, by the way. This is the simple reaction, right? Now for this, ROR is equal to K H2 I2. So here 1 and 1, because coefficient is 1 and 1. So for them we will use the coefficients which are simple reaction, right? For example, I'm giving a reaction which is basically formation of HCl. Okay, H2 plus Cl2 makes HCl, and I ask you to write the ROR, which is rate of reaction, and you wrote ROR is equal to K H2 Cl2 So I'll say this is the wrong, because this is not simple reaction. It is a very complicated, it is a complex. This is a complex reaction, right? And actually, if you want to know the rate of reaction for this, it will be, the rate of reaction for this is basically K H2 Cl2 0 0. Basically it is a zero order reaction, right? It is zero order reaction. And how I found this? By experiment. Or you can say by looking at the slowest step. By obviously it is a complex reaction, so when I was looking at the steps of the complex reaction, the step which was quite slowest, that is known as rate determining step, and I wrote the coefficients of that rate determining step, right? So I hope it is clear to you that in simple reactions we use a stoichiometric value, but in the complex reaction we see the rate determining step. So if you have any kind of curiosity